हेलो दोस्तों, आप सबका स्वागत है बायजूस एग्जाम प्रेप गेट यूट्यूब चैनल पर। और मैं आ चुका हूं आज सॉइल मैराथन के साथ पार्ट 2 के साथ। कल हमने किया था फेस डायग्राम, सॉइल कॉम्पैक्शन, सॉइल क्लासिफिकेशन, इफेक्टिव स्ट्रेस, और आज हम करेंगे दोस्तों परमेबिलिटी। इसी ऑर्डर में, जिस ऑर्डर में बता रहा हूं उसी ऑर्डर में करेंगे। परमेबिलिटी, सीपेज, कंसोलिडेशन, शीयर स्ट्रेंथ, अर्थ प्रेशर और शैलो और डीप फाउंडेशन। उम्मीद करता हूं सब स्वस्थ होंगे, बढ़िया होंगे। और जैसा कि हमने ऑलरेडी हिंदी चैनल पे एक शॉर्ट बना भी दिया है हम दोनों ने कल रात को, आप उसको देख लीजिएगा, जिसमें हमने बताया है कि आज जो पहले 3 को आने वाली थी सर, फिर 7 को आने वाली थी, 7 को भी नहीं आ रही है अब एडमिट कार्ड। तो बिल्कुल पोस्टपोन के बारे में कुछ नहीं कहा है ना, हम कह रहे हैं आप इन सब अफवाह मत आओ। जब वो होगा हम आपको बता देंगे, ऑफिशियल नोटिफिकेशन आ जाएगी। किसी दोस्त के बहकावे में या किसी ग्रुप के बहकावे में नहीं आना। पोस्टपोन हो भी सकता है, नहीं हो सकता, उन्होंने कुछ नहीं बोला है ना। लेकिन हाँ ये जरूर है कि ये जैसे कि सर आप बता भी रहे थे, एक बार ईएससी का एक बार बता दीजिए।
हाँ, as you have seen last year, what happened that there were so many speculations that gate is going to be postponed, gate is going to be postponed, and till last date I remember people were saying it is going to postpone, but exam was conducted, right? But engineering services examination, it was postponed. So you can say if we see these two examination now, so there are the higher chances. The word chances is important here. There are higher chances that ESE may get postponed in comparison to gate examination. We are very clear about this, that we are not saying exam will be postponed or any news is there. No news is there, and you don't even have to go inside all these things. You don't have to engage yourself in all these things. Yesterday also I have told you, and in the class I took in the online classroom program, where I told you, you can write this down right now, and later on let me know. I have told you that this is definitely going to happen. There will be 2 teams from now on. One will be like, please postpone the gate exam, and other team will be, no, we want it to be on the same date. But we are on the side of technicals. So please focus here only. Focus on your preparation. Do not worry about all these things.
Okay. So I forgot that there is English channel, so initially I said in Hindi. So guys, again let me tell you that yesterday we have done phase diagram, compaction, soil classification, effective stress. Today we will be doing in the same order in which I am telling right now, that is permeability, then seepage, then consolidation, then shear strength, then earth pressure, then shallow and deep foundation. Everybody, good morning guys. Please share the session so that everybody can join. Everybody, come on guys, please like and share the session so that more and more people can join and have a part of the soil foundation, soil part 2. Okay. So guys, till now they have nothing said about postpone. But guys, as the admit card is getting delayed, so there is one thing very confirm, that they are thinking of something, that whether we have to take it at right time or not. That is very sure, because if they are very 100% sure that it will be on the given dates earlier, that is 5th, 6th and 12th and 13th, then they will release the admit card. Admit card has been made, hai na? All the centers have been decided.
Obviously.
Okay, the only thing is they are just planning. Okay, and if we are guessing that what will be the outcome of planning, that will be time waste. Rather focus on studies. Okay, if many of you are demanding that it should be postponed because my preparation will be then more good, let me tell you one thing, this is a competition exam. Here you don't have to score good. Here you have to score relatively good. And when the time is increased for you, it will not be increasing only for you, it is increasing for everybody else. Cutoff will increase if the paper level is same. So don't ever think that with more time you will get more time to complete your syllabus. That will be for everybody else. Okay, so that will not affect in any way, because here you don't have to score good, you have to score relatively good. Anything you would like to say, sir?
Same thing I would like to say, that it doesn't matter. See, money and time, it is never enough, right? Every time you will feel like I should have more. What, suppose my salary is X and there is someone whose salary is 10X. So I will feel like, oh my god, if I would have 10X salary, I would have done so many things. Why that person is not doing all those things? Because that person is thinking my salary is too less. I hope my salary would have been 20X, right? Same happens with the time as well. It is a relative examination. When we say this in your sessions also, that if exam will come very tough, or maybe when paper will come more tough, you should not be sad, you should be happy, because it is tough for everyone, right? Each and everyone is going to give the same paper. So you don't have to worry about these things. Exam is relative here, so you don't have to worry about all these things ki bhai, we should have more time, we should have, there's no point of all those things, because anyways you have got sufficient amount of time. Pura ek saal ka time mila hai, right? Engineering services, you may say that nahi, 1 year nahi tha, because 18 July was the examination date last year, and this time it is on 20th Feb. Earlier it used to be on Jan to Jan, right? So please relax about all these things, and only one and the latest update is this only, that they are going to, IIT Kharagpur is going to announce the admit card shortly. That is it. There is nothing else about it, and if something will come up, we will let you know. That is what we do. Okay? So I think you should share the session now with each and everyone, with your friends, and let everybody know that soil mechanics part 2 is on. And remember, today sir is going to cover each and every concept. Yesterday also same thing happened. As soon as sir closed the session now, he just said, "Arey sir, I had to complete so many things, but I was not able to do that." You know why? Because it is not a revision. It is actually going like a basic classes, right? Each and every subject, each and every topic is being discussed here. Okay, so that is good for you, by the way. So please share this session with each and every friend, even if the friend is starting from the beginning. Koi nahi, bhejo usko. It is important, very important session. And also, I hope you all are doing your own revision with this. Okay, chaliye. I think start karte hain.
Okay.
And stage is all yours. Thank you so much.
Okay.
Bye bye. See you. I'll see you at 5 p.m. Okay. So with transportation part
2. Okay. So guys, this is about me. Most of you already know me. Just let me again tell you. My name is Abhinav Negi, having 10 plus years of teaching experience. Done my MTech from IIT Delhi in Geotechnical Engineering. Got All India Rank 164 in 2012. You have to score a better rank than this. Mentored more than 20,000 students in offline for more than 8,000 hours. These are my subjects. Right now I am doing soil mechanics, from which I have done my MTech as well. Now moving forward guys, these are faculties that are regularly helping you in YouTube and app. Okay. Now guys, let me just mute my mobile. Okay. So you can, whatever I'll be teaching you here now, I'm sharing the Telegram PDFs in Civil by Abhinav sir. Okay. Whatever I'm teaching you, the PDFs of those. Okay. The important updates, the important links I'm sharing in my Telegram Civil by Abhinav sir within 2 minutes. Many people already, those who are in my Telegram, they know that I share everything within 2 minutes here in my Telegram Civil by Abhinav sir. This is the MSQ schedule. Okay, yesterday Joshi sir has taken environment. Now guys, it will be Anuj sir will be taking structure and PERT CPM. Anuj sir will be taking structure and PERT CPM. And tomorrow on 8th of Jan, that is Saturday, I will be taking MSQ. Okay, on 8th of Jan, I will be taking MSQ tomorrow. Okay, guys, now let's come to the permeability. Everybody, every commando, how is the Josh? Everybody ready? Yes, every subject will be done here in Hindi MSQ channel as well and here as well. In the marathon way as well. Everybody please let me know how is the Josh. Are you ready for this? Okay. Now guys, permeability, that is represented by K. Okay. What is this? Let me tell you. Guys, Darcy says that velocity of the flow is directly proportional to hydraulic gradient. What is hydraulic gradient? Hydraulic gradient is HL by L. Head loss per unit length. Head loss per unit length. What is all this, sir? I am not getting, sir. Guys, suppose this is a soil sample. Suppose this is a soil sample, and here the soil sample is connected by a water head here. Suppose the head of the water is H1, the height is H1. Okay, and here the suppose the height is H2. Okay, so there is a head difference. Here the energy is more H1, there the energy is less H2. Here the energy is more H1, there the energy is less H2. Okay. See how the energy is more, sir. I am not getting, sir. Suppose let it take this as datum. Let this as datum. Okay. So consider any point. Let it be this point. So velocity head is always 0. Velocity head in soil is always 0, because if it is rest, velocity is 0. If it is moving, then velocity is very, very small. Not like Usain Bolt. Velocity is very small. Okay, 10 to the power minus 8 meter per second in that way. Okay, so velocity head is 0. Then my friends, even if it is moving always in soil, we take velocity head 0. Datum head, the height from datum is 0. Pressure head, see how much is the pressure? Gamma H1. So pressure head is H1. So total head here is H1. Okay, sir, got it, sir. Similarly, this point, velocity head is always 0 in soil. Okay, datum head, height from datum is always 0. Pressure head here is H2, height of water is H2, so pressure head is H2, total head here is H2. So total head here H1, total here H2, total here H1, total head there H2, total head there H1, total head there H2. So water will flow from H1 to H2. Water will flow from H1 to H2. Oh, sorry, from this point to this point. Why? Because there is energy difference. Here head is H1, there head is H2. Here head is H1, there head is H2. So there is an energy difference. So energy difference, therefore water will move. So velocity of water is directly proportional to hydraulic gradient. Hydraulic gradient is HL by L. What is HL in the figure? Head loss, H1 minus H2 by L. So more is the gradient now, more with speed water will flow. More is the gradient now, more is the speed with water will flow. Okay. So velocity is directly proportional to I, and that constant is, to remove the proportionality sign, it will be K into I. It will be V is equal to K into I. I hope you got it. K is the coefficient of permeability. Okay, guys, this is called as velocity. Okay, but true velocity. Okay, this is discharge velocity. True velocity or seepage velocity. True velocity or seepage velocity is given by V dash, and that is given by V by N. N is porosity. N is porosity. This is discharge velocity. Now what is the difference, sir? Guys, this is the true velocity. V dash is equal to V by N, and porosity is always less than 1. Volume of voids by total volume. So porosity is always less than 1. Therefore, V dash is greater than V. Therefore, V dash, that is true velocity, is greater than discharge velocity. Sir, what is the difference? What is the difference between the two? Guys, this discharge velocity na is actually, discharge by total area. Discharge by total area here. Total area. Okay, and real velocity is true velocity, because actually the true velocity discharged by, if water is not flowing from the whole area. Water is not flowing from the whole area. Water is not flowing from the whole area. Water is only flowing voids. Okay, if this area, whole area is not empty. This is not a pipe. Whole area is not empty. Water is only flowing from the voids. So it is Q by area of voids. Okay, this is Q by area of voids. Have you got it, everybody? Please let me know in the comment section. Please let me know in the comment section. Everybody, please let me know in the comment section. Have you got it, guys? Everybody? Okay, so this is permeability, guys, and when the permeability we have to find in parallel to bedding plane, then K equivalent is equal to, also written as Kx, is equal to K1 H1 plus K2 H2 plus K2 S2, so on, upon H1 plus S2. This is equivalent formula. Okay, K equivalent. Okay, now my friends, okay, Santu, here in perpendicular, K equivalent is equal to, also written as Ky sometimes, is equal to H1 plus H2 plus so on, upon H1 by K1 plus H2 by K2 plus so on. This is Ky. This is Ky, and always, guys, this Kx is always greater than equal to Ky. Kx is always greater than equal to Ky. Perpendicular is always more than the, parallel is always more than the perpendicular. Okay, why? Because parallel is something like arithmetic mean. See, K1 plus K1 plus K1 plus K1 plus K1 H1 times, plus K2 plus K2 plus K2 plus K2 S2 times, upon H1 number of values, number of terms. That is just like a arithmetic mean. And here it is a harmonic mean. Here it is a harmonic mean. So always arithmetic mean is always greater than equal to harmonic mean. Okay, yes, guys, in any between, if you have any doubt, please let me know. If in between you have any doubt, please let me know, guys. I'll be more than happy to help you in any way. I'll be more than happy to help you in any way. Please let me know. Okay, now the value of K, coefficient of permeability, is this. Okay, and when the permeability is very, very less, it can be treated as impervious also. Okay, it can be treated as impervious, not permeable. Okay, because the value of discharge you are obtaining or permeability is very, very less. Okay, now, guys, V is equal to Ki, na? This is coefficient of permeability na. Similarly, true velocity is Kp by I. Kp is coefficient of percolation, and V dash is equal to, I just told you, V by N. So my friends, from here V by V dash is equal to K by Kp is equal to N. Kp is coefficient of percolation. Kp is coefficient of percolation. Okay, so if we are relating V, that is discharge velocity, that is discharge velocity is discharge by total area. Okay, and V dash, true velocity, is discharge by area voids. So if you are relating total velocity with I, if you are relating total velocity with I, that is discharge velocity with I, that is coefficient of permeability. And if you are relating discharge true velocity, that will be coefficient of percolation. Okay, any doubt till here, guys? Please let me know. Please you ask your doubts also in the between. Okay, now please do this question, guys. MSQ, although I'll be taking MSQ tomorrow also. MSQ I'll be taking tomorrow 8:15 PM also. Okay, of soil of Hindi channel. Please let me know the question. Then we'll be going to the seepage chapter, guys. Bye. Which of the following statement is correct in the context of capillary pressure? When there is capillary pressure, which of the following things will be correct? Which of the following things will be correct? Water is under A, B, C. Four options, guys. MSQ, everybody please reply. Come on. MSQ, yaar. Teja, Mansoor, okay. Grishma, good. Grishma, good. Teja, good. Everybody, Aman, Mansoor, good. See, water is under tension, correct? Pore water pressure is negative. In capillary zone, it is negative. Okay. Effective stress increases, yes, guys, because U sigma bar is equal to sigma minus U. So U is negative. U, so minus U. So minus U will be plus. Minus U will be plus. Okay, capillary pressure is more in coarse grain soil. No, yaar. No, yaar. Guys, something formula is like this, na? 4 sigma cos theta upon gamma W into D. If diameter is more of voids in coarse grain soil, bigger voids, so H will be less. H will be less. In moti, in thick capillary tube, water rise is less. In thick capillary tube, water rise is less. In thin, water rise is more. So in coarse, diameter is more, H will be less, so less pressure. Got it or not? Got it or not? Got it or not? Please let me know. Got it or not? Any doubt to anybody? Okay, guys, come on, like and share the session in every group so that more and more commandos can join in. Everybody. Okay, now Flownet, very important. Very important. Devnath, मैंने हिंदी चैनल में एक शॉर्ट बनाया है. I have put a short in Hindi channel. You can see it later. Now Flownet, very important. And guys, as it is very important, so I am deriving it. I am showing you the complete figure. Please be patient. Please listen it very carefully. Okay. First of all, before Flownet, let me tell you one more thing here. Let me tell you here also. No. Let me tell you here. Guys, critical gradient na is equal to G minus 1 upon 1 plus E. What does this mean? What does this mean? At this gradient, if there is upward seepage, see, sigma bar net is equal to sigma bar plus minus HL into gamma W, plus for downward seepage, minus for upward seepage. Guys, please understand the whole mystery. Please understand the whole mystery that I'm telling you here. Everybody. Guys, what they see up when there is this sigma bar na is what we studied yesterday. This sigma bar is what we studied yesterday when there is hydrostatic condition. When there is hydrostatic condition, this sigma bar is the effective stress at any point and under hydrostatic condition that we have studied yesterday. Or I can write sigma bar old under hydrostatic condition. When water is moving or when there is a seepage, then effective stress is not the old one. Then if see, guys, suppose there is ground level and suppose there is water. Okay, suppose gamma sat is equal to 20, gamma w is equal to 10. This is 2 meter. Everybody please reply. What is the effective stress at point P? What is the effective stress at point P? Gamma sat 20, gamma w 10. Gamma sat 20, gamma w 10. Gamma sat 20, gamma w 10. This is 2 meter. This is 2 meter. Gamma sat 20, gamma w 10. So gamma submerge will be gamma sat minus gamma w, it will be 10. Okay. Now effective stress at point P is equal to gamma submerged 10 into 20. This is right when no seepage, that is hydrostatic. And this answer will be wrong in seepage condition. In seepage you cannot write effective stress 20. Now everybody enjoying it. Now everybody enjoying the concept. That here gamma submerged into H 20 is correct when there is hydrostatic condition. Unless nothing is mentioned in the question, you have to assume hydrostatic. That answer is correct. And if there is seepage, answer is not correct. Answer is not correct. So getting now everybody can understanding the concept. So when there is seepage, sigma bar net, when there is seepage, in that case sigma bar net is equal to sigma bar old, that is 20 when there is no seepage, plus minus HL gamma W. HL is head loss, gamma W is unit weight of water. When there is up plus downward seepage, it is plus. When there is upward seepage, it is minus. Guys, plus is no effect. Plus is no worry. Plus is no worry. Plus is having no worry. Good. Sigma bar is more love. Interaction between particles, I told you yesterday. More love. More love is sigma bar is more. More love between the particles. But minus is a worry. Minus is a worry because effective stress is reducing. And at this gradient, I am not going in derivation. At this gradient, effective stress is 0. So there is no contact, quicksand condition. No contact, quicksand condition. That time, effective stress is 0. Okay, quicksand condition, piping failure, anything. And factor of safety is critical gradient by this. Okay, now coming to here, everybody, very, very important. See, let me explain you here in this figure only. Suppose there is a sheet pile and water level here is this much and water level here is this much. So there is a head loss of how much? Here 10 meter, here 1.5 meter. So head loss of 8.5 meter. Getting or not? Getting or not? Getting or not? Head loss of 8.5 meter. Everybody got it? Great. Head loss of, so whenever there is head loss, everybody, whenever there is head loss, so water will move. Guys, everybody, not only water, anybody in this universe goes from high head to low head. Everything in this universe goes from high head to low head. Everything in this universe. So high head to low head, water is moving. Like this. Like this. Water is moving. Water is moving. Water is moving. So these are flow lines. These are flow lines. Let me make that water with different color. These are flow lines. So number of flow lines are always 2 extra. See, this also you have to make flow line and this also. So these are flow lines and number of flow fields. Number of flow fields. So number of flow lines are how much? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 5 minus 1 is equal to 4. Number of flow fields, that is NF. NF. Or either you don't want to see in this way. Either you don't want to see in this way. Yes, Shakti. Yes, Shakti. Yes, Shakti. HL is different for upward and downward. Can you explain this, sir? Shakti, head loss or effective head, how to find? Guys, see, Shakti, in case of upward seepage, HL is head loss yet to occur, जो अभी होने वाला है जब तक वो अपनी डेस्टिनेशन तक पहुंचेगा. And in downward seepage, HL is head loss that has occurred from starting point to that point. How much head loss has occurred? So NF is 4. So either two ways. One is make the flow lines 2 extra, 1 and 1 is 2 extra. So 1, 2, 3, 4, 5 minus 1, that is 4. Or leave all this. Water is going from here, water is going from here, water is going from here, water is going from here. 1, 2, 3, 4. NF is 4. Like this you can do. Like this you can do. Now number of equipotential drop. Here all equipotential drop means all are having same energy. All are having same energy. All points are having same energy. All points are same energy. Same energy. Same energy. All points are having same energy. So this red one is equipotential line. Equipotential line. 2 extra. See, these all are having also same energy, na? Same head, same datum, velocity 0 in soil mechanics and same pressure head. Similarly, this is also na same datum, same velocity head, same pressure. So equipotential line is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So number of equipotential drop. Number of equipotential drop is 9 minus 1. That is 8. That is 8. That is 8. Or leave all this. Here I told you 2 ways. Here also 2 ways. Number drops from here to here 1 loss. Guys, here all have same energy. 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 But this and this are not equal. Because water is moving now, so here energy is little bit loss, little bit more 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 loss. So from here to here 1 drop, 2, 3, 4, 5, 6, 7, 8 like this. Again 1 from here to 1 drop, 2 drop, 3 drop, 4 drop, 5 drop, 6 drop, 7 drop, 8 drop. Any way you can go. You can go from here as well. 1, 2, 3, 4, 5, 6, 7, 8. From anywhere it will be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let me again tell you. Whatever is the given in the question. Whatever is the given in the question. Whatever given in the question. And let me just make it this. Bye bye. Bye bye. Now let us see. See, water level is here is this. Again telling you commandos. Again telling you commandos. Head loss is equal to 8.5. So what is number of flow fields? 2 ways. Lines is 1 flow line. Water is going here now from high to low pressure, high head to low head. Water 1, 2, 3. Make 2 extra. Here, and this extra. So 1, 2, 3, 4, 5. 5 minus 1 is equal to 4. Either this way you can do, or another way is 1 water going from here, here. 4 ways. Number of flow field 4. Equipotential line, equipotential line. Make 2 extra. This and this. So number of equipotential drop. So lines are 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 1 is equal to 8. Or another way is from here to here 1 loss, then second loss, then third, fourth, fifth, sixth, seventh, eighth. 8 loss like this. Any way you can do. Understood everybody? Now the question is the seepage loss. The seepage loss is given by K into H into NF by ND. K is given. Where is K? K is given. Okay. H is 8.5. NF and ND is given. Calculation, I am not wasting time. Okay. PM, you can see my seepage chapter. I have taken the most complex problems in the world and I have solved this from 3 methods. You can see that there. You can see that there. Have you understood, everybody? Okay, whatever is the answer coming. Any doubt? Enjoyed the Flownet? That whole jal, that whole net is called Flownet. That is obtained from the solution of the Laplace equation. Everybody, have you understood all? Enjoyed? Now this one, the value of critical hydraulic gradient. IC is equal to G minus 1 upon 1 plus E. In IC always equal to 1, guys. Not exactly, but around 1. Why? If 1 is not coming in your exam, that means you are doing some mistake. If 1 is not coming in your exam, then it means that you are doing some mistake. How? I am very sure that it will be, around 1. How I am very sure? Because see, G is around 2.6 to 2.7. G is around 2.6 to 2.7 and E for sand is around 0.6 to 0.7. E for sand is around 0.6 to 0.7. So here 2.6 minus 1 is around 1.6 and here also denominator is also 1.6. That's why, guys, it will be around 1. Everybody, please let me know, have you enjoyed or not? Understood or not? Any doubt? Any doubt? No. Hello, Rupesh. Rupesh, please share the session. Now, what the question is asking, the value of critical gradient, that is 2.65 minus 1 upon 1 plus E. E we have to find out. Bulk density is this and saturation, degree of saturation 70%. So, gamma T is equal to 20 is equal to G plus S. S is 0.7 into E, 1 plus E into gamma W, unless mentioned, we will take 9.81. So from here, from this value, you can find E. You can find E and put E here. And put E here, you will get IC. Okay, from this expression, you can find E and you can put E here. Then you can find, guys, the value of quick hydraulic gradient. Of getting or not? Please let me know. Please let me know. Have you understood? Have you understood? Okay, this is the code. What is the seepage velocity? Vt is equal to discharge velocity by N. N is the porosity. So water ratio is 0.5. So N is equal to E upon 1 plus E. So 0.5 upon 1.5. So N is equal to 1 by 3. So discharge velocity is 5 into 10 ki power minus 7 upon 1 by 3. That is, everybody. Great. Excellent. Excellent, friends. Okay. Any doubt if anybody is facing here? Any doubt if anybody is facing here? No. So guys, what we have done till now, we will be doing, we have done this is only in ESC. Compaction we have done this. Vertical stress, see, 2 chapters that are very less important, that I will not be taking in this marathon. That I will be not take. Might be after gate we can take it, because for gate they are not important. So we have done this. Okay, seepage, permeability, effectiveness, compaction, that is not in the syllabus. We have done this. We have done proper phase diagram also. See, these 2 things I am not talking because that is not very important for gate exam. Hi Julie, after a long time you are here. Okay, so yes, now the remaining thing we'll be doing here. This, and soil exploration also will not be doing, because not very important, only area ratio formula is required there. Okay, so ready for the consolidation? Should I increase my speed or decrease my speed, everybody? Should I increase or decrease? Should I increase or decrease my speed? Everybody, please let me know. Increase or decrease? Increase, Sakti Singh. Little increase. Okay. Okay. What about others? Increase. बहुत अच्छा लग रहा है क्लास करके. Okay, Julie. Okay. So guys, see, settlement of soil can be due to, see, soil has what? Soil has solid particles plus water plus air. So how it can be compressed? It can be compressed by compression of air. How the soil can be reduced volume? By compression. By compression, or something is removed. Either by the compression or something is removed. That's why the volume will decrease. Guys, how my volume will decrease? Either I'll compress my stomach, or I will, from a knife, a 30 gram or 300 gram cut and throw it out. Same thing. Either I compress it or I remove something from here. So either compression, see, air voids are treated as incompressible. Solid or zero. That is by definition, water, solid, air are treated as incompressible. Water, solid and air are treated as incompressible. Now expulsion of air is what? Expulsion of air is what? Compaction. And expulsion of water is called consolidation. So compaction we have done yesterday, consolidation we will be doing today. Okay. Now I'll tell you in a very good way. All these things I will understand in very good way. So this is compaction, this is consolidation. So our chapter is now consolidation, compaction we have done. Now see, what is all this? Yeah, sir, let me tell you guys. Guys, 99.999% questions will be coming from this topic. And by default, consolidation by default means this only. Consolidation by default means this only. Okay, now see. Suppose this is my soil, solid, water and air. And suppose Joshi sir is putting its weight here. Joshi sir and his friend. And let it be only Joshi sir. Joshi sir is sitting here in front of me only. So Joshi sir is putting his weight. He is doing gym these days. Gain so much muscles. So he is compressing it. Joshi sir is compressing it. Okay, Joshi sir? Okay. Now, having so much muscles, now solid cannot be changed. There is no person in the world that can reduce the solid. So guys, some air will be compressed. Some air will be compressed. That is called compaction or immediate settlement. SI or immediate settlement. Now if Joshi sir is with his friend, important friend, and they are putting more weight, let me just correct it. Okay, Joshi sir? Now, where is pink color? Okay. So let it be now more weight. So more weight now. So this air void is theoretically, I am assuming all air voids have been gone. Practically, guys, out of the millions of air voids, 1 or 2 will be there. You are not Rajanikanth. Okay. Yes, Rupesh, he is in front of me, Joshi sir. So, with all his permission, I am talking this. So, with sufficient amount of load, practically out of millions of air voids, few will be left. You are not Rajanikanth, but theoretically I am assuming all air voids have been removed by sufficient load. Okay. So this is called immediate settlement, SI, or this is called compaction. Why it is immediate? Because the compression of air voids will take no time. Immediate. Now if again some load is applied on this, now it is saturated soil. So first step is what? Compaction. That is why in any coaching across India, the first thing should be taught compaction. That's why I told you compaction in part 1 and consolidation in part 2. In a partially saturated soil, always the compaction will be occurring first. Always compaction will be occurring first. No. Sandhu, my favorite is Shahrukh and Nana Patekar. So always compaction will be occurring first. Now the load is applied again. There is no air. It is saturated soil now. All load is taken by water, and water comes in excess for water pressure. Water comes in excess for water pressure, and water comes in excess for solid will not be changed. Water comes in excess for water pressure, and water starts dissipating. Water starts dissipating. Solid water. So here the volume change is consolidation. Consolidation, also called as primary consolidation, that is S1 degree, and that is secondary consolidation S2 degree. So removal of air is very fast process, compaction immediate, and removal of water is consolidation, that is slow process. It will take 3 years, 4 years. Consolidation will take 5 years. Compaction is immediate. Consolidation will take 5 years, 6 years, 7 years. Consolidation will take some much time. Consolidation will take much time. Okay, because why consolidation will take much time? Because the water move speed is 10 to the power minus 7 meter per second, 10 to the power minus 9 centimeter per second. Very slow water is moving, not like Usain Bolt clearing 100 meter in 9.6 seconds. So here will be this settlement is consolidation. Then what is secondary consolidation? That is only feasible in plastic soils. Okay, and it is rearrangement of particles. Guys, have you ever gone to village? Joshi sir, have you ever gone to village? Yes, Joshi sir has gone. In village now, when you take wheat, then you go to the, what is in English we call to chakki? Chakki? Mill. Okay, mill or something to crush the wheat, to make it to crush the gehu, to make it wheat. Chakki na? Okay. Where we are producing from the farms the wheat, the thing gehu we obtain, we are producing it to flour, wheat. Suppose we put that in a sack, in a poly bag, and if we are not compressing it, we are seeing it as it is. So due to its self weight also the particles will rearrange. Due to the self weight the particles will rearrange. Due to the self weight particles will rearrange, that is secondary consolidation. Due to self weight particles will rearrange in the dense formula. Guys, these things will be having empirical formula that will never be going to ask in GATE. Only out of the last 30 years 0 time this is asked and this is 1 time asked. So whatever I am telling you consolidation after this time, everything is primary consolidation. Whatever I am teaching you now is primary consolidation, that is removal of water. That is the formula for immediate settlement. That is compaction. Okay, but that is not at all necessary. So guys, in SOMNA, every time we see soil is homogeneous, isotopic, Hooke's law is valid. Similarly, in soil, we assume soil to be semi-infinite. We always measure the depth of clay, depth of sand, depth of gravel. We never measure the area. At which much area water table is at the 3 meter depth. So always the change is semi-infinite. Always depth is finite, area we treat as infinite. You always said 3 meter clay, 2 meter sand, but you never say that 3 meter clay up to how much area? Never. Okay, so all semi-infinite. So all change in delta V by original volume is due to height, because area we are considering to be infinite. No change in area. And that is this I have taken the derivation also, that is delta E upon 1 plus E naught. Now the NCC soil. What is NCC soil? NCC soil means earlier in the soil the Kavva Biryani person in run picture, very thin person is sitting, and now suppose great Khali is sitting present, and past was very thin person. That is NCC soil. NCC soil means today's stress is maximum. So OCR value is less than or equal to 1. Present stress is more. OCC soil means in past Khali was sitting very, and now past stress is very much and today's stress is very less. And OCC value is greater than 1. Give maximum stress in past is more. Okay, what this will make difference, I'll tell you. First of all, what is this coefficient of compressibility, guys? If you make a graph of sigma bar, sigma bar and void ratio, that will be something like this. The slope of this will be AV. Guys, if more compressing, we are more compressing, E will be decreasing and sigma bar will be increasing, because sigma bar is the thing between the particles. Sigma bar is the contact force between the particles. So if we are compressing it, sigma bar will increase. The contact force between particles, that is sigma bar, and E is the void ratio will decrease. The slope of this curve is AV. Coefficient compression, guys, if the same thing we make with log scale, then for NCC soil, this is a straight line and slope of this is CC. Guys, for now, what is the difference for OCC and NCC? For OCC soil, this will be like this. For OCC soil, the graph will be like this, and slope is CR. Guys, OCC soil means that past the maximum stress has been applied. Maximum stress has been applied in the past. Maximum. And today's stress is very less. So it will not cause much settlement. In NCC it will cause settlement, because past was very less. And see, if a very thin, so this in this bag, you fill the wheat, and a very small kid is applying the force, 3-year-old kid, it will not compress much. Then I come and I compress, so it will be compressing, the settlement will be more. But here, if in the bag there is wheat and already I have applied the force past, but now a small kid will applying the force, that will not cause much settlement. Similarly, here void ratio will not change much. E is changing very slowly. Here E is changing very fast, because already the stress has been applied in the past very high magnitude. So now settlement will not be much. That coefficient is also called coefficient of recompression. OCC is, this is CR, the slope of OCC soil. Okay, so this is the formulas of delta H, that is consolidation means primary consolidation. So 1, 2, 3. Guys, what is MV? MV is coefficient of volume compressibility is equal to AV upon 1 plus E naught. Okay, AV upon 1 plus E naught. Delta H is settlement, H naught is initial height, delta E is change in void ratio, E naught is initial void ratio, H naught is initial height. Okay, CC is the coefficient of compression, E naught is initial void ratio, H naught is initial height. Okay, and all these effect change in sigma bar has to be calculated at center of the layer. Suppose this is the layer of clay of 5 meter where I want to find settlement, then delta sigma bar will be at 2.5. Delta sigma bar I will be taking at 2.5. Okay. So these are the formulas for consolidation. Now guys, one more thing. Guys, since consolidation is time taking phenomena, consolidation, it will take time. So if I want to find at what time what is the settlement, then this is this. TV is equal to CV into T by D square. CV is coefficient of consolidation, that is K upon gamma W into MV. From this formula 2 or 3 times questions have been asked in GATE. CV is K upon gamma W into MV. They have given that MV of two soils are in the ratio of this, permeability is in the ratio of this. So find CV, very simple. CV is equal to K upon gamma W into MV. So TV is time factor that depends on degree of consolidation, capital U. Now what is capital U? See guys, if total settlement has to be 10 centimeter and it has been settled by 3 centimeter, if total settlement has to be 10 centimeter and it has been settled up to now 3 centimeter, that means 30% is the degree of consolidation, 30% has been occurred. If total settlement has to be 10 and till now it has occurred 7 centimeter, that means 70% degree of consolidation has been occurred. If total settlement is 10 and it has occurred 10, that means 100% degree of consolidation. If total settlement has to be 10 and 9 has been occurred, that means 90% degree of consolidation. So TV is equal to when degree of consolidation less than 60% or 0.6. This is the formula. When there are two formulas giving the same answers, I am taking this one. When degree of consolidation is greater than 60%, this is the formula. So less than equal to 60%, this formula, greater than 60% is this formula. CV is, that is constant for a soil, and D is the drainage path. For single drainage, see if there is rock, so water will go only here. But if they are both side permeable soil, so water can go here, here. That is single drainage, that is double drainage. If this height is H, so D here is equal to H and D here is equal to H by 2. Okay, in double drainage. Yes, for same degree of consolidation, the TV is constant. So TV is, I told you, TV for less than 60% this, for greater than 60% this. CV is a thing that depends on soil. T is the time, D is the drainage part, single drainage it is H, double drainage is H by 2. Now what time it is this? Guys, if you are writing TV for 30% degree of consolidation, this time is the time for 30% settlement to occur. If TV you are writing for 80% degree of consolidation, so this time will be for 80%. If this TV you are writing for 90% degree of consolidation, putting 90 here, so this time will be time required for 90%. Everybody, any doubt, please let me know. Everybody, any doubt, please let me know. This take as a homework. Okay. Guys, one more thing. First of all, do this. Draining from top and bottom, that is double drainage. Settlement of 2.5 centimeter in 4 years and ultimate settlement of 10 years, 10 centimeter. However, later on it is find out there is no drainage at the bottom. It was only single drainage. Yes, CV is constant for soil. Everybody please like and share the session. Please let me know. Guys, see, when ultimate settlement is 10 centimeter, ultimate settlement will be again 10. Many times I told you. Okay, because suppose in this bottle, if you put two holes, suppose you put two holes, 1 and 2. So when double drainage, water will come faster. But total bottle is, if it is 0.5 liter inside it, so even if it is one single drainage or double drainage, total settlement will be 0.5 liter only. If the water inside is 0.5 liter, if you put one hole or two hole, water will come only 0.5 liter only. Okay, so double drainage will make it faster, but total water will be coming same. Okay, so if the time required for 50% degree of consolidation for clay with single drainage is T, then the time for double drainage is how much? TV is equal to CV into T by when single drainage, D square. Okay, that is single drainage. Now double drainage, TV is equal to CV into T dash by D by 2 whole square. Okay, now everybody see, this will be 4T here. Okay, T dash will be T by 4. Double drainage time will be requiring less, not 4T. Santu, it will be double drainage, how time will be 4 times more. Double drainage time will be less, na? Wrong. Everybody is saying wrong answer. Sagar, Aman, wrong. Grishma, wrong. Santu, wrong. Guys, in double drainage time you are taking saying more. In single drainage time is T. In double drainage time will be more. Naresh Meena. Okay, great now. Okay, but guys, that is not very simple, na. It is not always like this, very simple. It is not so simple as you are thinking. Guys, here when you divide this thing, when you divide this and this by this, when you divide this by this, then since it is same degree of consolidation, since you have written this, that's why TV and TV is cancelled. Since you have written same sample, that's why CV and CV, because CV depends on soil. Okay? So same sample means CV is also same and depth is also same, D and D. So always it is not T by 4, 4T, it is not like that. If here it is written as 60, here it is 50% consolidation, here it is 60% consolidation, answer will not be T by 4. If here it is 50% consolidation, here it is written 70% consolidation, answer will not be T by 4. Then you have to make here TV by pi by 4 U square and here TV for 70% consolidation differently. Understood my concept or not, what I want to tell? That is not always in double drainage it is T by 4 or single drainage is 4T. It is not as simple as that. It is not as simple as that. Have you got it, guys? Have you got it, guys? Okay. So these are the assignments I am giving to you all. Okay. So enjoying, guys, till now? Enjoying, guys, till now? Okay. So let me ask Joshi sir to come to tell you something. Everybody, please put a heart sign for him.
Thank you so much, sir. Yeah, what a beautiful thing sir has written, na? Stars can't shine without darkness, right? So, sir, did you tell them GI method?
GI group? No, group index I didn't tell.
Then I'll, because I have that in highway. So I was preparing the PPT only for your second transportation part 2, right? So how is it going, everybody? Like, as you have expected, anything else, like you were expecting something else, sir will come and do that or do something else? Ninja sir, always love from Pune. Thank you so much. Always love from, although I'm right now in Noida, so love from Noida, but always love from Agra to each one of you. All right. Okay. So another thing is that that is very, very important to understand, that stars can't shine without darkness, right? And that is the only reason why you should never get disappointed when something bad happens. So many bad things happen with everyone. It happens, by the way. So when I look back, and I'll tell you a story. I'll tell you a quick event that happened yesterday only. So my younger brother, he was upset. He was feeling, because some of his my younger brother, his friend got job, and he is still preparing for Indian administration services, right? Civil services ke liye he is preparing, and suddenly he got this news that his friend has got a job in a good company and they are going for party. So he called my brother that you also join. So he was upset about it, that my friend has got the job and I'm still doing nothing. Because while you're preparing, you feel like you have achieved nothing, because there is no visible results, right? You can't even show your achievements at that time, but you are actually preparing. So I told this thing to him as well, that don't worry, if something happens with you, it happens for a reason. And at the end of the day, each one of you are going to get what you actually deserve, right? Remember this one thing. So do you remember even a single friend of yours who is doing nothing right now?
No, everybody is, even in lockdown, doing something.
Even my sir is having age. Sir, आपकी age क्या है?
by age. No, I never calculated date of birth is 1989. Might get 31, 32.
So sir is 30, 32, so his friend obviously must be doing something, but my age is 26. So my friends also, they each one of them are doing really, really great. I can't even say, I can't remember even a single one who is not doing something which you can say is not good, right? So everyone is going to get what you actually deserve. So don't worry. And when I said this thing to my brother, he said that these things are very good when you say them, but you don't know how it feels like. This is what he said. So I told this thing to him also, and I'm telling you this to you also. When you will come to my age, when you will come to sir's age, when you will actually come out of this phase, that day you will understand that I was right. That day you will understand that whatever I was telling you was correct, right? So maybe today you must be feeling, yeah, it is very easy to say all these things because you have a job, because you are standing in front of a camera and people are watching you, you have your name on YouTube. It is very easy for you to say, but it's not true. We have seen that phase also, and we come out of that phase. So we know how it feels like to be there, and we know how it feels like to be here as well. Okay? So never get disappointed if something bad happens with you. Always remember, something is happening, then it is happening for a good reason. I did not, like, my name was not there in the list of placement for LNT.
Okay.
Because they were only considering those who have pointer more than 9, and I had 8.8. So my name was not there. I was very, very sad. Very sad. I did not even had my lunch or dinner on that day. Even on the next day, I didn't had anything to eat something good, right? But today, I actually feel lucky that my name was not there, because whoever's name was there, they are working there right now also, but they are not happy. So many times I got call from them that they want to work with us here at this place, right? So it happens. If something is happening, don't worry, just shine, 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 because without the darkness, star can never shine. आई होप यू गॉट दिस, जो भी मैं बोला आप लोगों को. हाँ जी, समझ आया? डिड यू फेल्ट इट समवेयर हियर, इधर लगा, राइट? सो जस्ट बी काम, do your good, like whatever you did yesterday, do something better today. That is the only thinking that you need to have. Simple, right? Moving on to the shear strength.
Okay.
Sir, do you agree with me?
I have 100% agree.
Right, so continue. I hope you understood the point.
Okay, so guys, let's continue with the shear strength. That was a motivational booster for all of you. Now see guys, every time soil fails in shear, है ना, soil landslides you have seen in Facebook, in YouTube videos, the soil fails in shear. So the strength is given by two things, cohesion and friction angle. Cohesion in two ways. Cohesion in two ways: by electrostatic attraction between two particles. That is usually in clays, because clay there is charge separation. And also apparent cohesion. Apparent cohesion. Apparent cohesion means it looking like a cohesion. Means when there is a negative pressure. Guys, see how vacuum cleaner is working. That in vacuum cleaner we produce negative pressure. Okay. So we produce negative pressure, so everything comes from high pressure to low pressure. So in vacuum cleaner, if you put negative pressure so all the dust particles will come towards the negative pressure, because everything in this universe goes from high pressure to low pressure. That's why the dust particles are attracting towards the vacuum cleaner. Okay, so my champions, my commanders, everybody काम भी उतना है करवाते हैं. Okay. So that is apparent cohesion, that in capillary regions, if there is negative pressure, then there is suction. Suctions means just like cohesion. Now friction angle is also helping in two ways. One is, my friends, friction between the two particles. If more is the friction, more is the shear strength. More is the strength, they will not slide. They will not slide. They will not slide if more is the shear strength. If more is the friction between the two particles. And also one more way, friction angle is like this is the particle, and another particle is also angular like this. Another particle is also angular, so there will be interlocking. So if there is more interlocking, more is the shear strength. If there is interlocking, more is the shear strength. Now, my friend, these are the, see, always you see the landslide failures. always you will see the landslide failures. Okay, all these are shear failures. Shearing of one wedge over the other. Shearing of one wedge over the another. All these failures are shear failure. Okay, so now my friends, shear strength is given by C and phi, and that is the shear strength. C plus sigma tan phi or C dash plus sigma bar tan phi dash. If you have C and phi as total stress parameters, you will use this. And if you have effective stress parameters, that is C dash and phi dash, you will use this. And this is a little bit more accurate. If everything is you have, then you should apply this. Nothing you understood. When I was also in the college, I don't understood what is the difference between C and C dash. What is the difference between phi and phi dash? I also don't understood. But let me tell you, I will explain you. You will understood. Okay. Now, everybody see, for clay, phi is equal to 0. Clay is a flaky shape. So there is not much angular things. So phi is 0. There is no interlocking. So shear strength is equal to C. Shear strength is equal to C for clay. For sand and NCC soils. NCC soils also behave as sand. Guys, C is equal to 0. So tau is equal to, C is equal to 0 sigma tan phi or sigma bar tan phi dash. Now what is the difference between C phi and C dash phi dash? Let me explain you. When I was in college, I never understood this. Guys, how, see, first of all, you have to understand one thing, that C and phi are not the inherent properties of soil. C and phi are not the inherent properties of the soil. C and phi are not the inherent properties of the soil. Depending upon different conditions, C and phi can be different. Depending upon the different conditions, C and phi can be different. Okay? That, guys, how many hours I will teach, that is not a fixed quantity. In Visakhapatnam, I have taught even 13 hours also in a single day, in offline, when I used to teach in offline. So how many hours I will teach, that is not a fixed property. Now, friends, everybody, please see, C and phi can be different for same soil on different conditions. Let me tell you. Suppose this is soil and you are applying a confining stress. Confining from all together, from upward, downward, everywhere. That is sigma C or sigma 3. From here, 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 everywhere. Here, 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 of spherical conditions. Now to break this, you apply sigma D extra. Only in vertical direction. Only total is becomes sigma 1. Okay, sigma 1 is equal to sigma D plus sigma 3. This green stress is from all around. Green stress is all around. Sigma 3 is also called minor principal stress. Minor principal stress. And sigma 1 is also called major principal stress. Okay, now this sample becomes something like this. From here, it is sigma 3. From here also it was sigma 3 acting. Here also sigma 3 acting, but we apply sigma D extra. So total sigma 3 plus sigma D is equal to sigma 1. Sigma 3 actually was acting from all around. Here, 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 everywhere. Now we apply more than sigma D from top to make it sigma 1. Now if I draw the Mohr circle for this, I hope you have seen the Mohr circle chapter of mine. Then Mohr circle will be something like this. Sigma 3, sigma 1. Sigma 3, sigma 1. Okay, and suppose at this sigma 1 it fails. At this sigma 1 it fails. Now take another sample. Another sample, take bigger sigma 3 now, bigger. Hold it bigger. Bigger, hold it from all around, all around, all around, all around. More sigma 3. So now you are holding it more, 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 you are holding it more. So now it is more sigma 1 required to break it, because you are holding it tightly. So more sigma 1 is required to break it. So now sigma 3 is more, so more sigma 1 is required to break it. Now the tangent of this, if you draw the tangent of this, if you draw the tangent of these two, that line is tau is equal to c plus sigma tan phi. C is the intercept here and phi is the this friction angle. Now if you work in sigma 3 and this another sigma 3, this sigma 1, this sigma 1, total stress, the intercept here and angle here will be c phi. But if you work here with sigma bar 3, sigma bar 1, sigma bar 3, sigma bar 1, the values obtained for the same soil will be c dash and phi dash. Getting or not? Getting or not? If you work here with sigma 3 and another bigger sigma 3 is sigma 1, bigger sigma 1, in terms of total stress, the value obtained are c and phi. If you put here in graph sigma bar 3, sigma bar 1, sigma bar 3, sigma bar 1, the value obtained are c dash and phi dash. Great, everybody. And if you want the complete analysis of this chapter, I have taken in Hindi channel. I have taken in Hindi channel the complete video, each and everything of shear strength. Triaxial test also I have taken the video. You can see that. You can see that. You can see that. Complete thing. Okay. Now the relation between sigma 3 and sigma 1 is this. And if it is bar, if you want to make it bar effective stress, then it will be c dash and phi dash. Then it will be c dash and phi dash in that case. Here everywhere it will be phi dash. Okay, so the vein shear test also not very important for gate. Guys, see, for those soils which can, from where I can put the sample from lab, from sample from field to the lab, the properties are not changed much. The properties are not changed much. That's okay, but if there is very sensitive soil, if there is very sensitive soil and the property may get changed, if there is very sensitive soil and properties may get changed, in that case guys, everybody, we have to, in that case guys, everybody, we have to do what? We have to do testing in the field itself. We have to do testing in the field itself. That is a vein shear test. Suppose the soil is very sensitive, if you bring it to the soil, to the lab and making sample, the properties will change, then what is the use for finding the C and phi? So do the test in the field, and from here the T is the torque required to rotate. This is inserted in the field, and T is the torque required to rotate it. D and H are a dimension. From here you can find Cu. Cu is cohesion here. Okay. Now direct shear box test. This is a test. We put sand here. It is suitable for sand. We put sand here, and we shear it off it like this. Okay. Here we are providing the load. Okay, and we are shearing off it. We are shearing off it like this. 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 Okay. So normal load is applied from here. Now how we do this here? We make a graph. Sigma and tau. Sigma and tau we make a graph. Normal load we apply something. N by A. And with some, here T is measured. With T it is failed. So 1 point we obtained. Normal load we applied 30 kg from here, and with T load it is failed. Shear off. So 1 point is obtained. Now another soil is put. Another sample is made. Another sample is made of same soil. Now bigger N by A is put. Bigger load is, now it is more compressing. Now if we compress it more, then more T is required. More T is required to fail it. So bigger N by A, bigger T by A. So if you join since sand, Sand is C0. So it will start from origin. So this will be the graph and that will be the phi angle. This will be the graph and that will be the phi angle. Now triaxial test is the same that I taught you. Sigma 3 applying here and sigma 1 applying here. That is the same. And guys, I'm not going in all these details of these 4 tests CD, CU, UU. The reason is only one thing. The reason is only one thing that I have already taught this in Hindi channel in detail. So I want, literally, if you have ever want to see type of triaxial test, you put the heading. Otherwise, you can ask me in Telegram. I will show you the video of that. Okay. Now, this has been done. Now, this and this is not important for GATE. That's why I'm not teaching you here. Now, guys, 3 chapters are left. Earth pressure, shallow and deep. Are you all ready? Are you all ready for that? Ready? Please put a heart sign on the comment box for the earth pressure chapter. I'm not getting your comments here. Not getting, only 2 people here. Teacher is applying full energy. 4 marathons I have taken. 4 marathons. SOM 1, SOM 2, Soil 1, Soil 2. And already in Hindi channel we are taking the complete marathons. Me and Joshi sir and other faculties. Okay, everybody please like the session yaar. Like and share. Like and share, guys. Okay, guys, see, whenever I'm making a retaining wall, so some load will be acting here on this, like this. Some load will be acting on this, like this, due to the soil. Okay, some load of this soil is acting like this. So here I am finding the lateral load, not the vertical load. That vertical load is found out in the vertical stress below chapter, that is Boisinghu and all that. Why I want to find the lateral load? Yes, Prakash Jordan, if you see what is the most important topic in slope stability, that is the Taylor stability. But if that chapter is important, answer is no. But if in that chapter, yes, Taylor stability is important. Now, this load I want to find out. Why I want to find this load? This soil is there. Why I want to find this lateral load? Lateral load, so that accordingly I will design the thickness of this retaining wall. Accordingly, I will design the thickness of this retaining wall. Okay, why these weep holes are made, I have already told you. Now everybody please listen to me. See, everybody please. Here I am making the rest case. Here I am making the active case. Everybody please see. Joshi sir, you also please. Please see, sir. This is passive case. Okay. This rest, this is active, this is passive. अरे कर लो मजाक. Joshi sir is seriously seeing here. He was making PPT for you all in the 5 p.m. Okay. Everybody, I'll tell you each and everything of this chapter here. This retaining wall. Ground level. When is the rest condition? When it is not moving, neither here away from the fill. This is fill. This is fill. When it is not moving away from the fill, not towards, not away, not towards. That is rest case. Okay. Active case means this is the soil when it is moving away from the fill. And this delta H upon H is around 0.2% in loose sand and 0.5% for dense sand. Passive case is when this is a retaining wall, height H, and the fill is moving towards the fill. And this delta H upon H is around 2% for loose sand and 5% for dense sand. Sir, First question. Sir, why it is coming towards the fill? Guys, there are other forces other than soil also, like wind forces, earthquake forces, inclination forces, eccentric forces. Due to any such forces like wind load, earthquake, it can come towards the fill also. That is passive. Now guys, what is the vertical stress here? That is gamma h. Horizontal stress is equal to K naught. In rest case, it is K naught. Active earth pressure coefficient at rest. Earth pressure coefficient at rest. K naught into sigma V. K naught into sigma V. So sigma h is equal to K naught is equal to 1 minus sin phi. This is the horizontal stress at any point. Vertical, you know, gamma h. Vertical we have done in total stress chapter, gamma h. Gamma h. Okay. Similarly here, if this is sigma v, vertical stress, what is the horizontal stress? So horizontal stress is active earth pressure coefficient Ka into sigma v, that is 1 minus sin phi upon 1 plus sin phi into sigma v. See this value is less than 1. This value is less than 1. Numerator less, denominator bigger. So here sigma h is less than sigma v. So this is minor principal stress here. This is major principal stress here. But guys, this formula is not the correct one. That is not the general case. General case is sigma h is equal to sigma v 1 minus sin phi 1 plus sin phi minus 2c 1 minus sin phi upon 1 plus sin phi. That is the general formula. That is the general formula. And that formula, this one is only for c is equal to 0. For sand. No, vertical stress is total here. Total. Sandhu, for effective I will tell you. This is total. Good question, Sandhu. So this is 2c minus 2c 1 minus sin phi upon 1 plus sin phi. When this is the general formula for horizontal stress. 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 Okay, this is the general formula. And when c is 0, so then we see this. When c is 0, then we see this term. Okay, and usually you write this. Okay, Sandhu, I'll tell you for effective how to do. Now here, everybody, if this is the vertical, that is total stress, total. So horizontal stress is equal to Kp into sigma v is equal to 1 plus sin phi 1 minus sin phi into sigma v. So Kp is greater than 1 here. You can see numerator is bigger than denominator. So sigma h is greater than sigma v. So this is major here and this is minor here. And of course, guys, nobody will tell you, but Abhinav Negi is telling you by feeling, if you put wall towards the fill, the horizontal stress will be coming more. And if here it is here, going away, so why the stress will be more? If something is going towards the fill, so horizontal will be coming more. Simple. But real formula is not this. This is only for c is equal to 0. The real formula is sigma v is equal to sigma h. Sorry. Here, wait. Sigma h is equal to sigma v 1 minus sin phi, ठीक है. And here sigma h is major, na? Sigma h is equal to, that is major, is equal to sigma v 1 plus sin phi 1 minus sin phi. Sigma h here is major, sigma v is minor. Okay, plus 2c 1 plus sin phi upon 1 minus sin phi. That is the general formula here. Okay. Now that are the cases, guys. Okay. This active earth pressure at rest we have done. Okay, but I want to let me clear the doubt of Santhu also. If water is also, what if it is effective stress? I am explaining you with a simple case. See, Santhu. Okay. See, if this is ground level and this height is h, okay, here it is gamma saturated or gamma summer, and water is also here. Now if I want to find the horizontal stress on this, if I want to find the horizontal stress on this or horizontal force, which is very most simplest case, then guys see, sigma horizontal is, let it be active case or any case k, whether it k, kp, k not anything, k into sigma v. Okay, now you know that sigma bar is equal to sigma minus u. So sigma h is equal to k. Sigma can be written as sigma bar plus u. So k sigma can be written as this I told you it is total stress. So sigma bar plus u. So sigma h is equal to k into sigma bar v plus u will be alone. U will be alone because water exact equal pressure here everywhere gamma h. Water is not like this vertical pressure more or horizontal less. No. Water pressure gamma h is equal in all directions. So if vertical it is u, so horizontal also u. So k will be 1 for water. So water exact equal pressure in all directions. So if I want to find horizontal stress, so horizontal stress is this and this. So k into this k, whatever ka, k naught, kp into sigma bar v, that is k into gamma summers into h, k into gamma summers plus water also, plus but water it will be gamma w into h, nothing k. So total if I want to showing you here, it will be k gamma summer h plus gamma wh. This is the total horizontal stress, not effective. Now if you want sigma bar h, then minus u. If you want sigma bar h, then minus u. So this will be subtracted. Have you got it, Santu? Good, Mansoor. Have you got it, Santu? Okay, unbraced cut. Guys, at what depth we can cut? The excavation? After that we have to provide bracing so that it will not collapse. After that we have to provide bracing. So what depth we can cut? That is called critical depth, and that is 4c by gamma root Ka. Of course I am not going in derivation. Okay, so Ka value for clay when phi is 0, 1 minus sin 0, 1 plus sin 0 is equal to 1. Okay, and factor of safety of any cut with any depth, any unbrace is hc by h. If you cut to less depth, factor of safety will be more. Okay, please do this question. Everybody, every commando, every champion. Okay. Sides caved in means sides collapsed. Sides caved in means side collapse. 6 meter is equal to 4c by gamma root Ka. So it is clay. Clay means 1 minus sin phi sin 0 is equal to 1. So 4c by gamma is 20 into 1 is equal to 6. C is equal to 20 into 6 by 4. So C is equal to 20 into 6 by 4. So it is 30. And shear strength is given by C plus sigma tan phi, but phi is 0. So it is 30. A option. Have you got it, all of you? Have you got it, friends, or not? Please let me know on the comment section. Please let me know on the comment section. Have you got it or not? Have you got it? Guys, everybody, please like and share the session so that more commandos can join in. Each and every one of you. Each and every one of you. Enjoying the session? Enjoying the session, guys, or not? Enjoying the session, guys, or not? Okay. So, moving further, guys, now to the this is shallow and deep is left, na? So, what is the strip footing? Strip footing is when the width is less and length is more. So, when length is 5 times of width, that is strip footing. Isolated footing means one column, one footing. Combined footing means one footing have more than one columns. Combined footing means when one footing have more than one columns. Raft footing means when in the whole area we make a single raft, concrete ki chaddar, a blanket of concrete, and all the columns are putting over it. That is raft foundation. Okay, net pressure intensity is this is pile foundation. Guys, what is the gross pressure intensity? That is total load. That is load of soil also. Gross pressure intensity. P by B square is the load of the column on the footing, and gamma dF is the load of the soil. What is Q net? Q net is the load that has come extra. So that is P by B square if soil is put in. So earlier it was gamma dF acting, na? Now it is this also acting. So what is this? That is P by B square. So according to Terzaghi, please everybody listen this formula very carefully, because from shallow foundation only this can be asked, most chances. Only this can be asked. So according to, see, everybody please see. This is important. Terzaghi is important. If this is a footing having some load, that is the ground level. This is the DF, that is the depth of foundation. Okay, so the total load it can bear. According to Terzaghi, is given by QU is ultimate load capacity. QU is ultimate load capacity. How I am looking like ghost? ऐसे पढ़ा दूं? Okay, let me switch on again. Okay, QU is ultimate load capacity is equal to C into NC. C is the cohesion. NC, NQ and gamma, don't worry about this. They are just function of phi. Their value will be given to you. NC, NQ and gamma, don't worry. Leave them. They are just the function of phi. The value will be given to him. C is the cohesion at the base. If cohesion is more is the strength, na? More is the bearing capacity. Plus Q and Q. NQ already leave NQ. What is small q? Small q is load acting here. Small q is load acting here. That is gamma dF. Guys, if more small q is acting on this, this will be stable. It will not tilt. Somebody is compressing it. The soil is compressing it. So this soil is helping us to increase the bearing capacity. This soil is helping because holding it, this Q is holding it, so it will not be tilted. Okay. Now, NQ is a constant. Now here, and one more term. Take half as a constant. B gamma, half n gamma is a constant. Now think of B gamma. B gamma is the extra stress over here at B depth. So whatever is the stress coming here extra, that is B gamma, because crack originates from here. Crack originates from here. So if here is more stress of soil, it is more holding the soil, not able to crack it. Not able to crack it. So B gamma is the stress below this. Okay, this is QU. And guys, Q and U is how much? Net. I just told you. Q and U is this minus gamma dF. This minus gamma dF. Q and U is net bearing capacity, that is other than gamma dF. So C and C plus this minus gamma dF minus Q. So this whole term minus Q. So it will be Q into NQ minus 1 plus half B gamma N gamma. I hope you are getting it. What is difference between QU and Q and U? QU is total bearing capacity. And Q and U is other than Q, whatever is the QU, na, suppose QU is coming 100. Then you can apply 100 load including the load of soil also. Q and U is, if it is coming 80 na, that means 80 you can apply extra load other than soil. Other than soil. So QU is the total load including the weight of soil that can be acted. Q and U is the total load that can be acted on the soil other than the load of the soil. Okay, guys, these formulas of Terzaghi are only giving for strip footing. For if the footings are circular or square or another rectangular, the constants are added like this. These are shape modification factors. These are shape modification factors. These formulas are for strip footing. If it is circular, square, rectangular, these shape modification factors are extra. Okay, guys, if it is clay, for phi 0, NC is equal to 5.7, NQ is equal to 1, and gamma is equal to 0. Put it here. Q and U is equal to 5.7 C. NQ is 1, so it's 0, 1 minus 1, 0, and gamma is 0, this term will be 0. So for clay, Q and U is equal to 5.7 C. Now, these are for strip footings. For circular and all other things are valid. All other modification factors are required. Now guys, see, if there is water table, everything, then this gamma will be gamma submerged. And here this gamma of zone 1, because gamma dF is of this soil. And B gamma is below this. So this gamma is of zone 2. Now you do all water correction factor formula without any help. The only thing is, in water condition, you have to apply the things in submerged way, effective stress. And here in this term, gamma should be of one zone, and the third term gamma of it is second zone. Everything I have written here as well, that you can see later on. These are for general shear failure. For local shear failure, guys, if there is local shear failure, that is phi less than 27 degree, in that case, guys, you don't have to work here with NC, NQ and gamma. There you have to work with NC dash, NQ dash and gamma dash. Guys, all these formulas are for general shear failure. If the failure is local shear failure occurs when phi less than 27 or 23 degree. In that case, you don't have to apply the formula NC, NQ and gamma. You have to apply the formula NC dash, NQ dash and gamma dash. And you have to apply this tan phi is equal to 2 by 3 tan phi m. Calculate from here phi m and find NC dash, NQ dash and gamma dash in terms of phi m. Okay, suppose phi is given to you 15 degree. Wait, I am explaining you with the example. Suppose phi is given you 15 degree. Then that is local shear failure. These formulas are for general shear failure. Then you apply tan 15 is equal to 2 by 3 tan phi m. Instead of C, you have to put 2 by 3 C. And calculate phi m from here. Suppose phi m gets 12 degree. So now NC, NQ and gamma will be for function not 15. They will be calculated for 12. पीएम भाई पूरा सुन लिया करो, शेप फैक्टर तो बता दिया रेक्टेंगल वाला, और डेप्थ फैक्टर इसमें होता नहीं है ट्रजागी में, शेप फैक्टर तो बता दिया। अभी अभी आए क्या, अभी अभी आए क्या? ओके, सो tan 15 इज इक्वल टू 2/3 tan phi m, tan 15 is equal to 2/3 tan phi m. Calculate phi m from there, suppose 12 degree. So there is NC, NQ and gamma here will be the function of phi m, that is 12 degree, not 15 degree. And instead of C, you have to write 2/3 C. Everybody got it or not? Please let me know. Water table correction factor accordingly you can do. Accordingly. Just you know na, in second term is for zone 1, third term is for zone 2, like that. Now there, according to this na, Scampton has given different thing. That Scampton says that bearing capacity will be equal to CNC. Simple formula. That bearing capacity will be equal to CNC, that says. But NC has given different formulas for different shapes. For straight, for circular, for rectangular. Scampton has given a very easy formula. Q is equal to bearing capacity is equal to CNC. Simple. Only one term, CNC. C is cohesion and NC is this. NC is this. Okay. More of these will never be asked in exam. Peck-Hansen never be asked in exam. Account of NCT is also not asked in exam. Let me tell you. Suppose na, the load is not acting at the center. Suppose some column is like this. Not acting at center. This is acting at some eccentricity here. So you make your area reduced, such that the reduced area, this blue one, is at the center of mass. Such that reduced area blue na is at the center of mass of this. This point is at the where load is acting na is center of mass of this blue area. Now all calculations, all safety checks should be assumed on blue area. You assume your area to be less. Only this blue area assume. Okay. So if this is this, now assume this much footing only and do your calculations for safety. Okay, SPT test, guys. What is SPT test? SPT test is, we put a borehole at the depth of foundation. We put a borehole at the depth of foundation and some load is applied on this. Some load is applied on this. And first 150 mm, how much blows are required? 1, 2, 3. First 150 mm is not counted. Next 300 mm is counted. First 150 mm is not taken. Next 300 mm is taken. And when next 300 mm is taken, that is value N. In that, overburden correction and dilatancy correction is done. And N value, refined N value is taken. That's it for competition point of view, GATE and ESE. But somebody may ask, Sir, you are doing this first 150 mm, how many blows are required? You are not counting. Next 300 mm you are counting. Then you are applying some corrections like dilatancy and overburden correction. Then sir, what is the use? Then what is the use, sir? What is the use? Guys, use I am telling you for practical purpose, but not in any of the theoretical exam it will be asked. In any of the theoretical exam, use will never be asked. What is the use? Let me tell you, there are formulas of Tank's formula. That all, see, many formulas are giving you the bearing capacity, na? Many formulas are giving you the bearing capacity, na? Terzaghi, Peck-Hansen. Many formulas are giving you the bearing capacity. Peck-Hansen is giving you, many are giving you. Okay, many formulas are giving you the bearing capacity. Okay. Similarly, there are Tank's formula also. Like Peck-Hansen, like Meyerhoff, like Scampton, like Terzaghi, there is a Tank's formula also. In Tank's formula, bearing capacity, this N is required. There is a huge formula that is not to be required for you, neither for GATE, neither for ESE. In that, N is required. Because what I observe many times that I am teaching, but now nobody is asking, sir, what to do with this N? You get this 300 value M, what to do with this? Nobody is asking. Guys, with this N, we are finding the bearing capacity in Tank's formula. That is not required. What is the value of N here? What is the value of N here? Please let me know in the comment section. What is the value of N? N is, first 150 is not counted, next 300 mm is counted, so it is 18. It is 18. First 150 mm is not counted, next 300 mm is counted, so that will be 18. Okay, so now, okay, one more thing is that plate load test. Plate load test is what we do. We excavate up to the depth of foundation, we put a plate, okay, whatever is the size of plate, BP, width of plate, BP is the width of plate, so excavation width should be 5 times of that. So what should be the depth of excavation? The depth of excavation should be same as the depth of your foundation. The depth of the excavation should be same as the depth of the foundation, and width of the foundation is whatever is the width of the plate, 5 times of that. We apply the load on this plate, we apply the load on this plate, we apply the load on this plate and calculate settlement, and also calculate how much load it can take before failure, that is QUP. Okay, so we find out from here settlement of plate SP and QUP. QUP is how much load, ultimate bearing capacity of plate, how much load it can take. Now we have some formulas. That QUF foundation, actually we want QF foundation, ultimate capacity of foundation. Actually we want ultimate capacity of foundation, that is for granular soil. QUP we obtain how much load it can take before failure from the experiment. BP we know from the experiment. BF is the how much we are designing the foundation. From here you find QUF, and for clay QUF upon QUP is equal to 1. How much is the QUP at whatever the load plate is failing at, whatever the load plate is failing at the same load, at whatever the load it is failing at the same load, foundation will also fail. Okay, and settlement of foundation upon settlement of plate you can find out from the experiment is equal to BF by BP upon BP plus 0.3 upon BF plus 0.3 whole square. This is for sand. BF by BP upon BP plus 0.3 BF plus 0.3 whole square, that is for sand. Settlement foundation can be calculated from here, and settlement of foundation upon settlement of plate is equal to width of foundation upon width of plate for clay. Settlement of foundation upon settlement of plate is equal to width of foundation upon width of plate for clay. Okay, so that are the things. Now this is already written here. Now if get guys, what I told you, okay, beauty Sunam, if you get the chapter name भी नहीं पता चल रहा है तो 2023, please give the exam of 2023. Okay, so guys, what I told you at the beginning, that how much depth we should excavate, at what depth we should do this experiment, we should do this experiment at the depth of the foundation. If you are planned to do the foundation at a depth of 3 meter, then this test also should be done at 3 meter. If you are lazy, you are not going to that much depth, then this much correction should be required on the settlement. This should be the correction that is required in the settlement. This correction is only when you are not going to the excavation, you are not going to the depth to carry the test. At what depth you are going to make the foundation. You are going to make the foundation at 3 meter. You are doing the test at 1 meter. So D2 is 2 meter. And then correction is required. Okay. Now, this we have already done. Now deep foundations. Now deep foundation is very easy and logical chapter. Total load acting downward on these piles, how much load it can take, how much loads these piles can take, Okay, that will be total load. How it can be? It will be QF plus QP. Total load, how much it can take, is equal to QF plus QP. P from point bearing, and if pile is going down, so friction is going upward. If this is the pile and QU is the total load acting downward, so QP is point bearing capacity, because from the base some reaction of the soil will be there, and also the friction. Guys, this friction is neglected in shallow foundation. Why? Because here the area will be too much, long pile, area will be too much, here area will be too much. So QF is having some significance. In shallow foundation, small area, not big length. So what is QF? Neglecting there. Okay, and if you want bearing capacity, Q allowable, if you want Q allowable, that will be QU by factor of safety. Factor of safety not given, take it 2.5. So this is the villain QU that is coming, load is coming, and helping is QP and QF. If QP is very greater than QF, it is called point bearing pile. If QF is very bigger, then it is friction pile. And if both are same, almost same, not much difference, then it is neither friction pile nor point bearing pile. Okay, so QU is equal to QF plus QP. Guys, you know Vibhishan. You know Vibhishan. Vibhishan has to help Ravan, but he has changed his party and he has helped Ram. Similarly, friction can also do something work like Vibhishan. Guys, friction can also do something work like Vibhishan. So this is QU. So this is QP helping, and friction has to be in this direction. But suppose there is a fill which is very recently placed fill, negative friction, QF, recently placed fill, recently placed fill is going downward due to settlement. Okay, recently placed fill is settling downward, so it is providing negative drag, downward drag. See, and if you want to see from friction is always opposite to the motion. So here pile is going downward, but soil is going more downward. So this new fill consolidating, pile is going downward, but soil is going with higher rate. So it is providing drag downward. Or you can say that with respect to soil, pile is going upward, because pile speed is less of going downward and soil speed is more going downward. So with respect to soil, this is going upward. So negative friction is opposite to the motion, downward. Either you can think this way, or you can think like that it is fill is consolidating, so it is providing drag downward. So here QF is opposite. Here QP alone has to balance QU and QF. Here QP alone has to balance QF and QP. QP alone has to balance Q and QF. And guys, one more questions are asked these days. Sometimes they ask pull out capacity. Can you please tell me what is pull out capacity of a pile? When pull out, what will be resisting it? If their QP that time, no. If guys, you are pressing me downward, so reaction will be coming at my foot. If you are pulling me upward, then there will be no reaction. If you are pulling me downward, then will be reaction at my foot. If you are pulling me upward, there will be no reaction. So at that time, only friction will be helping us. So pull out capacity answer will be QF. Pull out capacity will be QF. Now guys, let us come back. QU is equal to QP plus QF. QU is equal to QP plus QF. Let us do for sand. So QP for sand, point bearing is equal to some, what is load? Stress into area. Stress is Q into NQ plus half, what is the value of Q is equal to half B gamma N gamma. This value always has to take 0. N gamma is never given, it is 0. This is the stress into area base. Area, because QP is acting at the base now. QP is acting at the base now. QP is acting at the base now. So it is, for circular pile, it is pi by 4 d square. Okay. And NQ is the value that will be given to you. NQ is the effective stress at the base of the pile. Effective stress variation is only taken up to 20 d for dense sand and 15 d for loose sand. Thereafter it is taken constant. So if the length of the pile is more than 20 d in dense sand, so only calculate at only up to 20 d. That will be the Q. Or in loose sand, it only calculate at 15 d. After that, because it is constant. Okay, so QP is this much and QF is K sigma bar average tan delta. What is load? Stress into area. So area surface. Area surface for circular pile. What is area base for circular pile? Pi by 4 d square. What is area surface? Pi d into L. Pi d circumference pi d, circumference pi d into L. Circumference pi d into L. Okay. What is K? That is given here for less dense and loose. What is sigma bar average? That is average effective stress on the pile. Tan delta given here. Now clay, QP is equal to C and C into area base. What is load here? Stress into area. So if NC is not given, you have to take 9. C is the cohesion. What is QF? Stress, that is alpha C. Alpha is adhesion factor into C cohesion into area surface. So what is QF? Stress into area. Very simple. Now for group piles. Oh my God. Group piles very easy. I am telling you the trick. For sand, if there are 16 piles, group capacity QUG, group capacity is n times of QU. Calculate for single pile I already told you how to do. And for there are 16 piles, multiply with 16. There are 25 piles, multiply with 25. For sand it is very easy. Calculate for one pile, that I already told you. Then multiply it with number of piles. For clay, I am telling you again, what is efficiency? Suppose N into QU. Very logical, yaar. Suppose one pile has 100 capacity. So 16 pile are in group. Should be 1600, but ultimate capacity only 800. So it is 50% only efficiency. Suppose there are 16 piles. One pile is having 800 capacity. So 16 should have 1600. But suppose in group it is only having 800 capacity due to intersection of pressure bulbs. So 800 upon 1600, that will be 50%. Efficiency is equal to 100% for sand. QUG is equal to N into QU. For clay now also it is very easy. I am telling you the trick. Like now, this is a group. Clay, I am telling you a very important trick. Just suppose spacing is S. Guys, this will be total 2S plus D. Square pile, this is 2S plus D. Guys, come on here. Spacing is S and S. So 2S. So D by 2 here, D by 2 here. So D. So I am telling you, for clay, assume all this as single pile. Assume this single pile. Answer will come same. Assume this whole as a single pile. Forget these 9 piles. Assume this single pile. For clay, QP is 9, this C into NC. NC is not given, you to 9. Area base. area base will be this. Simple. Same formula for group as we have done for single pile, but take this whole as one pile. QF is alpha C. Alpha in case of group, now you have to take 1 into C into area surface. What is this area? 2S plus D into L. 2S plus D into L. This is 2S plus D into L. And how much is surface? 4. And this QP plus QF is equal to QUG for clay. And for sand it is very easy. Everybody give me Y or N. These are other formulas that are empirical. I am giving you in PDF. Everybody please give me Y or N. Have you understood or not? Everybody please give me Y or N. Have you understood or not? Please let me know on the comment section. Guys, the PDF I'll be sharing you in the Telegram Civil by Abhinav sir within the 2 minutes. Within 2 minutes I'm sharing you the PDF. And now Anirudh sir is coming today in Hindi channel. MSQ guys, very important series. MSQ very important series in Hindi channel. He is coming at 8:15 PM today, and tomorrow I'll be coming with soil. Soil tomorrow I'll be coming. Guys, have you enjoyed this? Please let me know. Have you enjoyed this? Please let me know. Dynamic formula I've given you. I'm giving you in PDF na PM. That is an empirical formula. Nothing teacher can do in that. Everybody. Okay, PM, you can ask me in Telegram if nothing is nothing term you can understood. Please let me know. I'll be happy. How you like the session, guys? Do you enjoyed it? Was it effective? Was it effective? Was it effective? Nobody is telling. Okay. So thank you guys. Now I'll see you tomorrow at 8:15 PM MSQ, and Joshi sir will see you today at 5 PM with transportation part 2. Thank you guys. Take care.